We're looking at different ways of inducing EMF. So we understand that whenever there is a changing magnetic field exposed to a conductor or other way around, so there will be induced EMF or current. Now we are trying to figure out how all can we have this? What and all are the possibility? See, basically we have to go back to flux, right? So everything starts with flux. So flux is given by BA cos of theta. Remember area, and this is your area vector, and then the magnetic field and stuff. How parallel they are, it depends on that. So we can accumulate charge at the end of a conductor by changing the magnetic flux. But how can we change flux? Well, we have to look at factors of flux. So factors of flux will include what and all? Well, it includes area clearly. So it includes area, it includes B, and also it includes, what is the other thing? Angle between them, theta. So three factors: area vector, magnetic field, and theta. Does it make sense? So as simple as that. Okay. Yeah. So we're trying to look at how all can we induce. So for induction and all of that, the phenomena or the picture that we need to look at is flux. And flux depends on all of this. So basically by changing magnetic field, by changing the area of the coil, and by changing the angle between the field and the area vector, we are able to change the flux, and so we'll be able to induce EMF, right? Let me show one of it. So here we have, oh sorry, this is motor, I wanted generator. So here what is changing? Is area changing? How is the flux changing? How is the current induced? Is the magnetic strength changing? Yes, angle is changing. See, the magnets are the same. They are fixed. The area of the coil remains the same. They are also fixed. So here I'm varying the angle, and so I'm able to do this. Get that voltage, right? So let's look at the theory now. Induced electromagnetic force can be generated through several methods, primarily based on Faraday's law of electromagnetic induction. Again, all the things that we are looking at is few possibilities. So you can find a lot of possibilities. There are many ways of inducing EMF. Okay, so you can web search that. Quite a few interesting ways. So current with water waves, as in ocean currents. Then we have generation of electricity with thermal inside the ocean. So there are quite a few ways. Wind blowing, right? There are many ways. Solar energy. So they are the main methods. These are the main methods. Here are the main methods, sorry. So changing magnetic field. So varying the magnetic field within a closed loop of a wire induces an EMF. This can be achieved by moving a magnet towards or away from the coil. This we have already seen. Experiment is already seen. Changing the current in a electromagnet near the coil. This too we have explained. Changing the area, altering the area of the loop exposed to the magnetic field can induce a EMF. For example, stretching or compressing a loop of wire in a magnetic field. This too we have taken up the experiments. Sorry, explanation, not experiment. Changing the orientation is what we saw. So rotating the loop within a magnetic field changes the angle between the magnetic field and the loop induces EMF. So this will be seen in detail. Relative motion, moving the coil related to the stationary magnetic field or moving the magnetic field related to the stationary loop induces EMF. So basically this is same as your first point. The faster the relative motion, the greater the induced EMF. Okay guys, a small introduction. We'll be studying a lot more on this.